We continue to believe that visceral fat is very, very important in the pathology of insulin resistance. Now, it's very, very difficult to understand what the events are which lead from visceral fat to insulin resistance itself. We believe that the visceral fat releases fatty acids, that the fatty acids go and enter the liver. This reduces clearance of insulin by the liver, which causes hyperinsulinemia, and the hyperinsulinemia then contributes to the degree of insulin resistance, because when insulin goes up, the cells become less sensitive to insulin. Now, it's very difficult to prove this sequence of events, because many of the things which are related to insulin resistance happen simultaneously. For example, release of fatty acids from the visceral fat and insulin resistance of the liver, which also involves storage of fatty acids by the liver as triglycerides, occur more or less at the same time. Some investigators have tried to claim, or have claimed, that liver triglycerides are the primary defect rather than visceral fat. They've done this by looking at patients and trying to relate liver fat storage versus visceral adiposity to the degree of insulin resistance. The trouble with that kind of study is that you have to do it on selected patients, and I don't believe that it's really critical in determining what the causation is or what the causality is in determining the degree of insulin resistance. Now, what is the importance of free fatty acids? Because we know that free fatty acids can come from the visceral fat depot. Many people have said that free fatty acids are not important because if you measure them under fasting conditions, the free fatty acid levels are not very different between obese individuals and normal weight individuals. A couple of years ago, we measured free fatty acids over a 24-hour period and found that whereas under fasting conditions the free fatty acids may not be different in those with visceral fat, at least in animals, in the middle of the night the fatty acids are much higher in those who have visceral fat depot. So we believe that the visceral fat contributes to the release of fatty acids from the visceral fat, and that it's really the nocturnal or nighttime free fatty acids that are most important in causing first insulin resistance of the liver, reduced clearance of insulin by the liver, elevated insulin levels in the blood, and then finally peripheral insulin resistance. So we still subscribe to the concept that it's the release of fatty acids predominantly from the visceral fat depot which is most important in causing the insulin resistance that we see in the metabolic syndrome, or the insulin resistance syndrome. Now, one question is, what makes the free fatty acids emerge from the visceral fat depot in the middle of the night? And we don't know the answer to that, but we think the sympathetic nervous system plays a very important role. So probably the brain plays a role in the overall dependence of the metabolic syndrome, but the visceral fat and the elevated visceral fat is critical to the development of this condition.